Good evening, children. Today I will explain about open vessel concept. Actually, in gas laws, first one Boyle's law completed, second one Charles law completed, and third one Charles law 2 or Galois law is completed. Actually, third one is Avogadro's law, but another one extra concept is there, that is open vessel concept. Okay, fourth one open vessel concept. In open vessel concept, open vessel means this is open vessel, means there is no closing, openly present. For example, in this one, some number of particles are present or some number of moles. For example, 100 moles of any substance is present in that open vessel. Okay, then if you increase the temperature, what you are observing in the number of molecules or number of moles of substances. If temperature increases, that number of molecules or number of moles of the substances decreases. So these two are inversely proportional to each other. So it is at constant, the condition is at constant pressure and volume. At constant pressure and volume, temperature is inversely proportional to the number of molecules or number of moles of a substance. So this is very simple. For removing the proportionality, T is equal to K by N. So this one move to this side. N into T is equal to K are constant. So for two gases, N1 T1 equal to N2 T2. Okay, sir. This is about open vessel concept. Fifth one, Avogadro's law. What is Avogadro's law? At constant temperature and pressure, the volume of given mass of a gas is directly proportional to the number of moles. If volume increases, the volume occupation is also increases. Means the number of particles filling is also increases. Simply, these two are directly proportional to each other. It is also write like this: V is directly proportional to the Avogadro number. So this is Avogadro's law. Okay. So from this one, this is the main equation. For removing the proportionality, we introduce one constant, proportionality constant. V is equal to Km. So it is V by M equal to constant. For any two gases, V1 by N1 equal to V2 by N2. V1 by N1 is equal to V2 by N2. Okay, this is about Avogadro's law. Okay, Nana? But for this one, we know that what is Avogadro number? That is N naught is Avogadro number. That is value is equal to 6.023 into 10 to the power of 23 particles. We know that this mole concept, based on the mole concept. Okay. Now, sir, V is equal to K into N, sir. V is equal to K into N. Where what is M? M equal to number of moles. We can express either in number of moles or number of molecules. molecules. But in most of the cases, we are using number of moles only. So V is equal to K by M. So V is equal to K into number of moles. What is the formula for number of moles with weight by volume? So weight by molecular weight. Weight by molecular weight. Molecular weight is taken as capital M. W is right like this. First write full form. Molecular weight. Then it is right like this. V is equal to K into weight means W. Molecular weight means M. Molecular weight means M. So M is equal to this M move to this side. M equal to this V move to this side. K into W by V. But weight by volume. What is weight by volume? Density. M is equal to K into D. M equal to K into D. Simply it tells molecular weight is directly proportional to the density. Here D is density. Density means weight by volume. So molecular weight is directly proportional to the density of the substance. This is Avogadro's law. Ideal gas equation. Ideal gas equation means actually ideal gases are there. I will explain later. Ideal gas equation means if you take any gas, the gas must be follows the ideal gas equation. Sir, what is ideal gas? Ideal gas equation is a combination of Boyle's law, Charles' law and Avogadro's law. Combining these three gas laws gives one equation. That equation is called ideal gas equation. Sir, what is Boyle's law, sir? What is Boyle's law? Boyle's law is V is inversely proportional to the pressure. What is Charles' law, sir? What is Charles' law, sir? V is proportional to T. What is Avogadro's law, sir? What is Avogadro's law, sir? V is proportional to M. Here V is common. V is common means V is directly proportional to 1 by P into T into M. But here proportionality is there. For removing this proportionality, we introduce one constant value, that is R. Here R is gas constant. Simply it is called universal gas constant. So 1 by P T. Yeah, this P move to this side, PV equal to, actually see this one NTR, but we are using so many cases. PV is equal to nRT. PV is equal to nRT. This is called ideal gas equation. Ideal gas equation. Okay, Rana? PV is equal to nRT. Sir, what about R, sir? Here R is called universal gas constant. Universal gas constant. Okay, Nana? Sir, these are the gas constant values. Very, very important. 0.0821 liter atmosphere. Kelvin inverse, mole inverse. These are common. This one common. Kelvin inverse, mole inverse. 0.0831 liter bar. Because we know one bar is equal to 1 liter. 1 atmosphere is equal to how many bars? I already explained. So 821, 831 liter bar Kelvin inverse, mole inverse. Here this is important and this is important. 8.314 joule Kelvin inverse, mole inverse. But 1 joule is equal to kg meter square second power minus 2. Write down. Kg meter square second power minus 2. 1 joule is equal to kilo pascal dm cube. Dm cube means liter. So kilo pascal liter. So 1 joule is equal to this one. 1 joule is equal to this one also. But in X, 8.314 into 10 to the power of 7. For joules, 8.314. joules. For ergs, 8.314 10 to the power of 7 erg Kelvin inverse, mole inverse. For calories, this value is 1.99, but it is approximately 2, so we will write every time 2 only. So 2 calorie Kelvin inverse, mole inverse. So here, these are the important values. In most of the cases, we are using these values in problems. So this is about ideal gas equation. Okay. Now, simply based on this one joule is equal to 10 to the power of 7 x. 1 joule equal to 10 to the power of 7 x. And 1 calorie equal to 4.184 into 10 to the power of 7 x. Okay, Nana? Right. Next, some other relations. We know that PV is equal to nRT. Here R is constant. N is number of moles or number of molecules. So for any two gases, formula is this T move to this side. Generally PV by T is equal to M into R. So this is constant. This is constant because R is constant. Number of moles also are expressed in constant, 2 moles, 3 moles, or everything like that. So constant. So for any two gases, P1 V1 by T1 equal to P V2 by T2. This is another expression for solving problems. And next one, sir, PV is equal to nRT, sir. N is number of moles. What is the number of moles formula? Weight by molecular weight. Okay. Weight by molecular weight. This M move to this side, V move to this side. Okay, no problem. Just V move to this side. So P is equal to W by V into RT by M. But we know that weight by volume means density. So P is equal to D into simply dRT by M. dRT by M. This formula is useful for calculation of density, pressure, temperature, or molecular mass. Or this one also write like this: M is equal to dRT by P. These two formulas are also important for solving formulas. Okay, right. This is about total gas loss, ideal gas equation. Now I will explain what is ideal gas. What is ideal gas? Write the running notes, all of you. Ideal gas means a gas which obeys means satisfy. A gas which obeys gas laws is called an ideal gas. Gas laws means Boyle's law, Charles law, and Avogadro's law. Simply, a gas which obeys ideal gas equation is also called ideal gas. I will tell again. Listen carefully. What is ideal gas? Ideal gas. First, write the definition. A gas which obeys gas laws. Write in brackets. Boyle's law, Charles law, Avogadro's law. Bracket close. Is called ideal gas. Or a gas which obeys ideal gas equation is called ideal gas. Okay, right. That is the first point. Definition of ideal gas. Okay, what about the remaining gases? If any gas is not satisfied, right? So ideal gas, it is assumed that intermolecular forces, the intermolecular forces between the particles are not present between the molecules of an ideal gas. Simply, an ideal gas which obeys gas laws means all Boyle's law, Charles law, Avogadro's, these three are satisfied. That gas has no intermolecular forces between the molecules. Okay, very simple. There is very free molecules are present. And so, in case if any gas is not satisfied the ideal gas, those are called real gases. But the real gases follows these laws at a particular conditions only. Under certain specific conditions, when the forces of interactions are practically negligible. At what conditions? At low pressure and high temperature. So, real gases also follows ideal conditions. At a particular specific conditions, what are the conditions? Low pressure and at very high temperatures. Real gases also can exhibit ideal behavior. Actually, real gases are not follows the gas laws. But at a specific conditions we maintained, they can act as an ideal, so somewhat small ideal gas behavior. Okay, right. Gas laws, ideal gas equation, ideal gas also completed. Now MCQs. So problems in Singh's book. Now next concept, diffusion and effusion. Sir, what is diffusion and what is effusion? You have to learn now. Sir, diffusion means it is one box. It is one big box. That box is separated with one wall. Now here this one is mixed with one gas, for example N2 gas. This one is mixed with another gas, that is O2 gas. Okay. So two separate gases are present in that box, and the box is separated by some one wall or any one plate. Now remove that plate. The two gases are combined. The N2 and O2 gases are combined. This phenomenon is called diffusion. But the condition is the two gases must be not reacted. Simply two or more gases are intermixing. That process is called diffusion. Okay, I will give the definition. Sir, what is about diffusion, sir? Very simple. You know that if you take one balloon, this is one balloon. Inside, of course, one gas is present. That is, for example, O2 gas is present. Now take one pin. Just what you have observed? That inside oxygen gas is present. That gas is passing through coming out through that small aperture. This is called effusion. Effusion means that inside the gas is coming to the outside. With a small aperture, through a small point is called effusion. Now write the definitions for these two. Now I will tell. First, write the definition of diffusion. The process of intermixing of two or more gases irrespective of density relationship and without help of external agency. Okay, next, effusion definition. Write down all of you. A gas is allowed to escape under pressure through a small aperture made in the wall of the closed container. Definition is completed. Here, made in the on the wall means for the balloon, that layer is called wall here. Okay, right. Now come to that very important law, Graham's law of diffusion or effusion. Next one, Graham's law. Graham's law of diffusion or effusion. Effusion means mixing of the gases, diffusion means escaping gas. Okay, for these two, this Graham's law is applicable. Sir, what is Graham's law, sir? First leave some place for definition, first all of you. Very simple. R R means rate of diffusion. So rate means what, sir? Rate means calculate for 1 second time. Calculate for 1 second time. In 1 second time, how much diffusion or how much effusion takes place. That is called rate. In 1 second time, how much diffusion or how much effusion is called rate here. So the rate R means rate of diffusion. Rate of diffusion is inversely proportional to the square root of its density. Means the gas density. This is one definition. Another definition, inversely proportional to the molecular mass. Another definition, vapor density. Vapor density. Now write the definition. Condition is at constant, you have to maintain constant temperature and pressure. At constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Enough, write only one definition. Of course, what is the another definition? At constant temperature and pressure, rate of diffusion of a gas is inversely proportional to the molecular weight of the gas. Another definition, at constant temperature and pressure, rate of diffusion of gas is inversely proportional to the square root of its vapor density. Okay, right. So it gives very simple explanation. For example, rate and molecular both are inversely proportional to each other. Means for any gas, if molecular weight is very small, the rate of diffusion is high. Okay. So simply, if for any gas, very simple identification. For any gas, molecular weight is lower, the rate of diffusion is higher. Rate of diffusion is higher. Okay. Right. And we know what is the relation between molecular weight and vapor density. Molecular weight is equal to 2 into vapor density. Remember at this point also. Okay. Now for two gases, first these are the important formulas. First one, and this is important. This is also important relations. The next one, for two gases. What is the formula? Apply for this one. R1 by R2 is equal to root over D2 by D1. This is equal to root over M2 by M1. This is equal to root over VB2 by VB1. Very simple, very simple. For two gases, this is based on one formula. Okay, Nana? Now, second definitions. First definition, three definitions are actually there. Now, second definition. Very interesting this is. No need to write the definition, just write the formula only. R equal to V by T. Rate of diffusion is equal to V means volume, T means time. Volume means volume of gas is diffused, means how much volume is diffused, and time taken for diffusion. For that, how much volume is diffused, for that volume, how much time is taken. That ratio is called rate of diffusion. So V means volume of gas diffused by T means time taken for diffusion. Okay, Nana? One more formula is there, that is R equal to N by T. N means T same as this time taken for diffusion. But N means number of moles of gas diffused. Right here, right. Number of moles of gas diffused by time taken for diffusion. Okay. So now apply the same for two gases. For first one, R1 by R2 is equal to V1 by V2 into T2 by T1. T2 by T1. Okay, but some conditions are there. First condition. That is condition 1. If these two are equal, means volumes are equal at different time intervals. This is for first time, this is for second time. For example, this is time taken for 10 seconds, second one for time taken for 20 seconds. But volume is same. If volume V1 equal to V2, then what is the formula? R1 by R2 is equal to T2 by T1. Okay, right. Then you can write number of formulas. This is equal to, already we know the formula. R1 by R2 is equal to root over V2 by V1. This is equal to root over M2 by M1. This is equal to root over VD2 by VD1. Number of formulas we can write. Because these relationships, based on these relationships, problems will ask. Okay, so just remember all of it. Okay, so next case, we can expect the next condition. If time taken in both cases, same. So if P1 equal to P2, then R1 by R2 is equal to V1 by V2. This is equal to, remaining are all same. Okay, Nana? Very easy and very interesting. Right? Completed. Next one. In this one, another cases are also there. Now, sir, what is the Graham's law definition, sir? At constant temperature and pressure. This is the first initial condition. Then rate of diffusion is inversely proportional to the square root of the density. Sir, if temperature is not constant, what are the changes you observed? If temperature is not constant, what you are observed the changes? Now we will discuss about these two only. First one, if pressure is not constant, okay sir, what is the relation? Generally, rate of diffusion is directly proportional to the pressure. If pressure is increases, rate of diffusion is also increases. Means the combination also increases, diffusion is also increases. Okay, na? So both are directly proportional. We know that R is proportional to 1 by root D, or 1 by root M, or 1 by root VD. So between these two, directly you can write R is equal to P by root D. P by root D or root M. In any formula, no problem. Okay, this is equal to P by root M. Okay, for two gases, how can you write? For two gases, R1 by R2 is equal to P1 by P2 into root over D2 by D1. Or this is equal to P1 by P2 into root over M2 by M1. Very simple. P1 down P2. Square root D is presented down, then D2 by D1. Okay, Nana? Right. Okay, sir. This is for if pressure is not constant. Next one. If temperature is not constant. Sir, what is the condition? It is, you don't know about this one. Listen carefully. R is directly proportional to the square root of temperature. Remember this one. For anything, if the rate of diffusion is directly proportional to the square root of the temperature. Remember, if temperature increases directly, so this we can write like this: R is proportional to T power 1 by 2. Means if direct temperature increasing is not possible because that are present in the mixing or present in the inside. Both gases in diffusion or effusion present in the container. That's why direct temperature application is not possible. Okay, remember that one. So R is proportional to root T. Right? That's why only square only we are applying. And we know that R is proportional to 1 by root D or anything. R is proportional to 1 by root D. It means R is equal to root T by root D. Means root over P by D. So for two gases, R1 by R2 is equal to root over P1 by P2 into D2 by D1. Instead of D, we can write M2 by M1 or VD2 by VD1. Graham's law is completed. Okay, Nana? Thank you very much.